Hi, I'm Devish. Today I'm going to show you my To-Do app which I have built. I'm going to click on register. I'm going to enter my email, my password. After it's registered, I'm going to log in. After that's done, I'm going to copy my API key. Now I'm going to enter it into my To-Do app. Now I can add or delete or create any task I want. Now I'm going to create a task like learn Docker, and that task has been created. With the same database, this task has been created inside the database and it's got an ID, and I can update this value too. I can also delete it, and it gets updated in the database. And as you can see, it's updated in the database. I can add tasks, delete tasks, create tasks, and all of this happens in real time. Now let's see all the backend of the database and the application. So first of all, as you can see, the database has three columns. The ID is a primary key and is a serial type and has the integer type, and the name is a varchar and it's got a particular size, and the pending is obviously a boolean. Let's look at the code. So this right over here is my Rust application. It can get the all of the tasks which are present in the database, and you can also test this from your own API client like Postman or Insomnia. It can add tasks and it can update tasks or can delete tasks, as you have seen. This is my init.sql file which is used to create my database or initialize my database. This file helps in the authentication to the database. It's got all the credentials hard coded right now, but later it will be using an env file securely. This can update tasks, fetch tasks, delete tasks, etc. This file is not really made right now, but it will be made for the API authentication. But currently we do have API support, API authentication support, so we don't need that right now. And this is the Go program. This is used for the API authentication, API key authentication, as you can see, and also API key generation when a new user logs in and doesn't have an API. This file is in particular for the API key validation which the Rust application uses, and it pretty much just calls the Go API to check if the API key is valid or not, and if it's valid the API returns it's valid and the Rust application proceeds. This is the Spring Boot Java application, and it's used to serve the API. And what does this API do? Let's see. As you can see, this is the user file and user controller, user repository, user service, web config, Kafka producer to register application. So as you can guess, this Spring Boot application is here to register our user, and where the user login happens, the user login happens in the Go file. So this Go file helps in the user authentication and API key generation, and this helps in the user registration, and it also sends the email into our Kafka. Not this file, but another file. It sends our email to the Kafka, but it doesn't do it directly. It actually just takes the email and gives it to a Python API, which actually puts it into the Kafka. As you can see, this Python script is used to put the email in the Kafka queue, or a Kafka topic, which is user email, and it also gives status codes. So right now we have seen all of the backend code. Now let's see the MongoDB database. But to see, this user has been registered with a password. Now right now the password hasn't been encrypted because I didn't want to make the app more complex, so I did not really use bcrypt. Now API keys are also stored over here, which the Go application retrieves. So there's different database for each service, as you can see. And of course we can use the API key. Let me just paste it over here and send the request to the Rust application, and it sends all the data. And as you can see, it's pretty fast. It's not a slow API at all. Now let's go and see the server code and what's actually happening inside the server. So this is a Rust application which is running, and it runs pretty well. This is the Kafka queue. Now let's talk about that after we talk about Spring. So when the to-do application is being used, like the tasks are being added, removed, or updated or deleted, this Rust file or the Rust program handles everything. And to use this Rust application, you're going to need an API key, and for that you're going to need a user. So to register a user, you're going to have to use the register user service, which is backed by the Spring Boot of Java. Now whenever it gets the user registration, it handles user registration and then sends the email to Kafka, as we've discussed. Now it doesn't do this directly, it just sends it to Python, which is using Flask, and it takes the email and sends it to the Kafka queue. As you can see, it got the request from the Java application and it has sent the request to the Kafka. Now, as you can see, Kafka has received it in the user email topic and has played it over here. Now in the future, I'll be adding functionality for Python to consume information from the user email topic and send a welcome email notification. And this of course is our little monitoring tab, which just sees any server load, how much memory is being used, how much disk space is left, what programs are running, has any program crashed, or is any program using too much memory. And this over here is my whole front end of the application. It's got all of the pricing, the to-do app, the sign up, the login, the landing page, all of these things. So this is my quick summary of the app which I have completed right now. Thank you.